Hello students, welcome to part 2 of section 4, periodic functions, stretching and translating graphs. Now today we're going to primarily focus on translating graphs. That's where you shift graphs. Rather than stretch them and compress them or squeeze them, we're going to shift graphs, right, left, up, down, all around. Alright, so for a couple of examples here, if you have, say, the absolute value of x, and you say plus something, that means you're shifting the graph up with the graph on the outside. Same goes for the square root of x. With the plus on the outside, you're shifting the graph up. If you have a minus on the outside, then you're shifting the graph down. You're shifting it down, whether it be absolute value, square root, something else. If you have a minus on the inside of an absolute value sign, then you're actually, now this is kind of backwards, you're actually shifting to the right. Draw a little right arrow there. And if you have a minus on the inside of a square root, you're actually shifting the graph to the right. You're taking the parent graph and moving it right. And then finally, if you have a plus on the inside, you actually go backwards. You go left. And if you have a plus on the inside of a square root, you also go left. So the inside numbers are kind of backwards, and they affect the x variable. The outside numbers are straightforward, up or down, affect the y. Okay, so what I've given you here is the parent function y equals the absolute value of x. It has a vertex at 0, 0, and then every output is positive, except for when you plug in 0. You get 0, of course. But if you plug in 1, you get 1. If you plug in -1, you get positive 1, -2, positive 2, so on and so forth. Now what I want you to do is take that graph, the parent function that you have memorized, and shift it by a factor of 3. So what does that mean? That means shift it up, down, left, or right. Well, the plus is on the outside, so that is this one. Oh, up arrow. That means I have to go up 3. So let's sketch our axes, and instead of starting at 0, 0, it starts up 3. And then everything else is the same. It goes up 1, right 1, and up 1, left 1. And if you want to make some ordered pairs, make a little table, that might help you. So that little plus 3 meant go up 3. Pretty easy. Well, what's it mean if you have a minus 2? Okay, look up here. Oh, minus on the outside, that means I go down. So I'm going to go down. I'm going to write this down 2. So take the original vertex and shift it down 2. And the slope hasn't changed. Up 1, right 1. Up 1, left 1. Make sure it looks like a V. Bada bing, bada boom, you done. Okay, now what if I put a -4 on the inside? Well, up here my little cheat sheet says minus on the inside makes it go, oh, it goes right. It's going to go right 4. Let me write that. So let's get ready to sketch it. Instead of 0, 0, move the vertex right 4, and it goes up 1. Whoop, sorry about that. It goes up 1, right 1, and up 1, left 1. Notice the shape of the graph hasn't changed. It's just been shifted. That's why we call that pink one the parent function. Okay, and finally, what about with a plus 2 on the inside? So plus on the inside means I go left. That's a left arrow. So left 2. Let's sketch that. Go left 2. That's where your vertex is. Up 1, right 1. Up 1, left 1. You're probably getting the pattern by now. And boom. So you just did a real basic shift on the absolute value of x in all 4 directions. Nicely done. Okay, let's kick it up a notch. Make it a little bit trickier. Alright, so what I want you to do here is write down everything that's happened. Well, what's this -3 do on the inside? Well, that means it's going to shift to the right 3. Let's write everything that's going to happen down. This plus 1 on the inside, that means you're going to shift the right vertex up 1. Alright? But, wait a minute, we also have this 2 on the outside. So if a 2's on the outside, is it going to multiply the y's or the x's? That's right, if it's on the outside, you're going to take y times 2. Y times 2, all the y values. And then finally, wait a minute, it's not just a 2, it's a -2. It's a -2. So that means you're going to flip, since it's on the outside, over the x-axis. All of the y values will become negative. All of the y values will become negative. Now, I'll give you a little hint here. Take the inside and set it to 0, whatever's on the inside, and solve. Now, the reason we did that is because that value will become the center of your absolute value graph. So what I would suggest doing is making a table and put the 3 in the center of your absolute value graph. When you plug in 3, you're going to get 2 times 0, you're going to get 1. So we can go ahead and start this graph. Alright, so instead of at 0, 0, we're going to go right 3, up 1. Now don't just go up 1 over 1, because remember you got this 2 out front that is messing stuff up for us. So let's plug in 4. Okay, well 4 minus 3 is 1. Absolute value of 1 is 1 times negative 2. Well, that's negative 2 plus 1 is negative 1. So 4 actually gives us negative 1. So notice the slope is not up 1 over 1 anymore. It's actually down 2 over 1 because it's been flipped and the y's are times 2. And use symmetry to get another point, down 2 left 1. That would be 2 negative 1. And if you want, plug in another point, 5 and 1. 5 will give you 2 times negative 2 is negative 4 plus 1 is negative 3. So it goes down 2 over 1 again. And down 2 left 1 again. And there you go. That's your V. Notice it must be a V because it's an absolute value graph. Alright, and finally, this is the hardest one I'm giving you. Alright, tell me everything that's happened. Tell me everything that's happened. Well, let's see here. It's going to go, what's the plus 1 going to do? That means it's going to be shifted left 1. What's the minus 3 going to do? It's going to take us down 3. The negative on the outside will flip us again. How's it going to flip? The same way the last one did. Flip over the x-axis. It's going to face down instead of up. And the center is the trickiest part of this one, because if you set 2x plus 1 to 0, the center is actually negative 1/2. So I would suggest when you make your table to start at negative 1/2. Plugging that in, you're going to get negative 3. Now we're off to the races. Let's sketch the graph. So negative 1, negative 2. You know what? I'm going to make this just a little bit larger. I don't like how limited I've made myself. So negative 1, negative 2. So negative 1/2, negative 3. Here's negative 1/2 down to 3. Boom. There's negative 1/2, negative 3. Okay, now I wouldn't jump a full unit in either direction because I don't want to keep plugging in values that contain a half. So jump a half to the positive direction and a half to the negative direction. When you plug in 0, you get 2 times 0 is 0, plus 1 is 1. Absolute value of 1 is 1, but there's a negative out front, making it negative 1. Minus 3 is negative 4, which means he will give you negative 4. Now, just make sure, folks, that it's facing down, because you told me at the beginning it had to face down. And just for giggles, 1 gives you negative 6, and negative 2 gives you negative 6. Now, you can graph these on your graphing calculator just to kind of check to make sure you've done your table correctly, but I'm not going to tell you how to do it. I'm going to make you figure it out, because I don't believe I've shown you how to do that before. If you got questions about that, ask me in class. Okay, now I've got a couple oddball problems that I want to do with you. Read along with me, please. You have a circle with this equation, x squared plus y squared equals 4. X squared plus y squared equals 4. Now you should remember from Algebra 2 that this is actually r squared, which would imply that our radius here is 2. Make that note. And the new center, when the circle's been shifted, is 5, negative 2. Actually, this old center, let me write that here, the old center, when there were no values affecting x or y, was 0, 0, was the origin. It was the origin. Alright, what is the new equation? And sketch both graphs. Alright, so here's our old equation. x squared plus y squared equals 4, where the radius is 2. Well, let's sketch that graph and see what it looks like. 1, 2, 1, 2, 1, 2, 1, 2. Center at 0, 0. Let me put that here. Center, 0, 0. And you go up 2, left 2, right 2, and down 2. And don't you dare make a diamond. Make it as circular as you can make it. I'm doing the best I can on my iPad app here. It's not too bad. Kind of looks like an oddball egg, but it's close enough. Alright, so what we've done here is the new center is actually 5, negative 2. Well, what is that doing then? That means it's shifting how far to the right? From 0, it goes right 5. Put that, let's draw the word right. And it goes down 2 from 0. Down 2. So the new center, instead of just x minus 0 squared, that's the way you could have thought about this. This was x minus 0 squared plus y minus 0 squared. Write that out. It'll help you when you're looking back at your notes. Instead of x minus 0, what's it going to be? Since it goes right, it's actually x minus 5 squared. Remember how the right is kind of backwards? Plus, instead of y minus 0, since it goes down, it's actually, since it's on the inside of parentheses, it's going to be y minus negative 2, which is really just plus 2 squared. Plus 2 squared. I'm going to scratch this out because that's not actually part of my equation. So, since it's on the inside, it's kind of backwards. Even though it shifts down, we put plus 2. Since it's on the inside of parentheses. Equals, the radius hasn't changed. The radius is still 4. Alright, so I'll do this one in pink. So we're going to go right 5, 3, 4, 5, and down 2. That's our new center. Radius hasn't changed. So the best way to do this is to go up 2, put a dot. Left 2, put a dot. Right 2, put a dot. And down 2, put a dot. And boom, 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 boom. Oh, that's a pretty good circle if I do say so myself. Where r is 2, and the center is 5, negative 2. Hopefully that brought back some memories from Algebra 2. If not, well, hopefully you know how to do it, because it's in this lesson, and it doesn't go away. We do a lot of this the rest of the year. Okay, finally, we're going to do part A, B, and C of this last example. Read along with me, please. Make sure you read along. You're going to need to copy this down, too. The graph has x-intercepts 0 and 4. 0 and 4. With a minimum at 2, negative 10. Where do the x-intercepts and the minimum occur on these 3 graphs? So what I've given you here are some shifts. Notice here I forgot my parentheses. So let's sketch the original graph real quick over here. 0 at 0 and a 0 at 4. And a minimum at 2, negative 10. That's right, 2 and down 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm guessing that this probably looks like a parabola. That's my guess. Technically, we don't know it for sure, but I think we can say that it's a parabola. Okay, alright, so what would the zeros, that's basically what x-intercept means, let's put that, the zeros, and the minimum, which is basically the vertex, let's put that, be of the following, of y equal f of 2x. Okay, well we have a k value of 2, and it's on the inside. Now remember, that's the weird one. That's the weird one. That's where you're running twice as fast. And when you run twice as fast, you get to your destination in half the time. You get to your horizontal destination in half the time. That means you cut the x values in half. In half. Alright, so I'm going to put the old zeros and the old minimum. Do this along with me. The old zeros were 0, 0, and 4, 0. The old minimum was 2, negative 10. Now I'm going to put our answers. The new zeros and the new minimum. This is so cool. I love this. Alright, so cut each x value in half and leave the y values alone. So half of 0 is just 0, comma 0. It hasn't changed. But half of 4 is 2. Remember, we're cutting the x values in half because we're running twice as fast. We get to where we want to go in half the time. And here, cut the x value in half. So in half of 2 is 1 and leave negative 10 alone. There you go. That's what the new zeros and the new minimum would be if we made this modification to our graph. Okay, let's try part B. I'll draw a circle here to kind of separate. So this time k is 2 again, but it's on the outside. So this affects the y values. And more specifically, the y values double. So take each of the old zeros and the old minimum and double the y values. Meanwhile, you leave the x values alone. That's supposed to say min. Okay, so here we go. Let's just fill in the blanks. So here's our old 0, 0, 0, the old origin. I'm sorry, the old x-intercept was the origin. So take y, which is 0, and times it by 2. Well, that's just 0. The origin is still on the graph when we stretch it vertically. Okay, what about the old 0, 4, 0? Well, leave x alone since we're stretching it vertically, but take 0, the y value, times 2. Well, that hasn't changed either. And that makes sense because we're pulling this graph up and down. We're not affecting it horizontally. The y value, if it's 0, is just going to stay 0. The x value stays the same. All right, but finally here, the old minimum, 2, negative 10, x stays the same, but negative 10 gets stretched. It gets pulled downwards. It gets pulled downwards. You leave the 2 alone, but you take 2 times negative 10. That's negative 20. That's the new minimum. That's the new minimum. Okay, and finally, this last translation. Now this time we're not multiplying, we're shifting. And what's it mean if you have a -1 on the inside? That right or left? You got it. That means we shift it right by a value of 1. Right, 1. So technically, what does that mean? Are we affecting x or y? That means we're affecting x. We take the x values and we add 1 to them. X values plus 1. That's what we do. All right, so my new zeros, let's figure out what they'll be. Just take the current graph and shift it right 1. Instead of 0, 0, it'll be at 1, 0. Take x is equals 0 plus 1. So that's 1, comma 0. And instead of 4, 0, shift it right 1. Where am I at? Oh, I'm at 5, 0. And finally, the new minimum. Let's see here. It was 2, negative 10. See it right here? 2, negative 10. But I'm going to take it and I'm going to bump it to the right one. I'm not changing the shape of the graph. I'm just shifting it, translating it to the right. So that 2 becomes, you got it, 3, negative 10. Very cool problem. One that hopefully you can do without the picture now that you've been stretching and translating like crazy people. So anyway, folks, that's all I got for this video. Work hard. I'll catch you later. Have a good one. I'm out.